Have you ever wondered why something with no weight at all could ever slow down? Tonight, we explore one of the cosmos' most beautiful mysteries, a question that reveals the hidden architecture of reality itself. If light has no mass, why is its speed limited? Imagine yourself drifting through the infinite darkness of space. Here, in this perfect void, there is no air to push against, no friction to resist, nothing at all to slow anything down. Now picture a photon, a particle of light, born in the heart of a distant star. It weighs nothing, absolutely nothing. It carries no mass through the emptiness, yet it always moves at exactly the same speed. Not faster, not slower. Always this precise rhythm. Why? If nothing holds it back, if nothing pulls on it, what invisible boundary keeps it from racing infinitely fast across the universe? The answer is more elegant than you might imagine. The speed of light is not really about light at all. It is about the universe itself, about the very fabric that weaves space and time together into one seamless whole. Tonight, as you settle into this journey through the cosmos, you will discover that light is simply a messenger, revealing a deeper truth about existence. The universe has a speed limit built into its foundation, a cosmic law that shapes everything from the smallest quantum particle to the largest galaxy. This limit is not a barrier that slows light down. It is the maximum speed at which reality itself can unfold, the rhythm at which the universe breathes, the tempo at which causes become effects. Every photon that touches your eyes right now has traveled at this universal speed, carrying information from across space and time. And as we drift deeper into this story, you will understand why this cosmic speed limit might be the very thing that makes existence possible at all. Imagine this moment. You are holding a flashlight in your hand. Your fingers rest gently on the button. You press down, and something extraordinary happens. Light shoots out into the darkness at an astonishing speed of 299,792,458 meters per second. Pause for a moment and consider what just happened. In the time it takes you to blink, that light could travel around the entire Earth 7.5 times. In a single second, it could reach the moon. This speed is so immense, so far beyond our everyday experience, that our minds struggle to truly grasp it. Yet this speed, vast as it seems, is not infinite. It has a limit. And that limit holds the key to understanding the very nature of reality. Now, here is something that will quietly shift everything you thought you understood about the nature of reality itself. Light has absolutely zero mass, not a little bit of mass, not the smallest measurable amount. Zero, nothing. It does not weigh anything at all. It is, in the most fundamental sense, massless. This might seem like a simple statement, but let it sink in. Everything you can touch, everything you can hold, everything you have ever experienced has mass. The air you breathe has mass. The screen you are watching has mass. Your own body has mass. But light, this thing that fills our world with colour and warmth, that allows you to see everything around you, has no mass whatsoever. So let me ask you something. If light truly has no mass, if there is literally nothing there to slow it down, no friction present in the emptiness of space, no air resistance in the perfect vacuum, then why does it not travel infinitely fast? Why does it stop at this precise number, 299,792,458 meters per second? What invisible boundary is light encountering? This is not a trivial question. This is one of the most profound mysteries in all of physics. And the answer will take us on a journey through the very fabric of space and time. Think about this for a moment. When you throw a baseball through the air, it gradually slows down. This happens because of air resistance and gravity, both of which act upon the ball's mass. A bullet fired from a gun will eventually fall toward the ground. The same reason applies. It has mass. Every object you have ever thrown, every ball you have ever kicked, every projectile ever launched, they all slow down, they all fall, they all stop eventually. This is the world of mass, the world we know from everyday experience. But light is different. Light has no mass whatsoever. There is nothing physical for forces to grab onto, nothing material to slow down. So why, in the infinite emptiness of space, does light have a speed limit at all? Consider the perfect vacuum between stars. There is no air, no gas, no dust, nothing to create friction, nothing to impede motion. In such a place, you would expect something with no mass to accelerate without limit, to reach infinite speed. Yet, light does not do this. It travels at a fixed, finite speed, always the same speed, never faster, never slower. Here is what we are about to explore together, something that may gently reshape your understanding of the universe. The speed of light is not actually about light itself. The universe has a cosmic speed limit built into the very fabric of space and time. And light simply happens to be the messenger, showing us this fundamental law that governs everything. This cosmic speed limit is not something imposed on the universe from outside. It is not a rule that could have been different. It emerges from the very structure of reality itself, from the way space and time are woven together. It is as fundamental to the universe as existence itself. Everything you are about to learn will quietly change how you perceive reality. By the time we finish this journey together, you will understand why you, sitting there right now in this moment, can never travel faster than light. You will understand why time itself is not fixed, but flexible. And you will see why the speed limit of the universe might actually be the only thing preventing reality from completely falling apart. You will also understand why the universe needs this speed limit. Why, without it, causality would break down, time would lose its meaning, and the very possibility of existence would vanish. Before we begin this exploration, consider supporting this journey by pressing the like button if you are ready to see the universe in a new way. Subscribe if you would like to continue exploring these deep questions about physics and reality. And leave a comment telling me where you are in the world right now and what time it is where you are. I am curious to know where people are when they encounter these ideas. Are you watching this late at night, unable to sleep? Are you taking a break from work? Are you somewhere peaceful with time to think? Share your story. I read every comment that comes through. These are the kinds of questions that connect us all. No matter where you are, no matter what time it is, we are all made of the same atoms, governed by the same physical laws, experiencing the same universe. And in this moment, we are exploring one of its deepest mysteries together. Now, let us start with what might seem like a simple question. What is light? I am going to give you an answer that might sound almost impossible, yet it is completely and verifiably true. Light is both a particle and a wave at the same time, not sometimes one and sometimes the other, both simultaneously, always. This is called wave-particle duality, and it is one of the strangest, most counterintuitive truths in all of physics. Our everyday experience tells us that things are either particles, like grains of sand, or waves, like ripples on water. They cannot be both, yet light is both. It exists in a state that defies our common sense understanding of reality. In 1905, A 26-year-old patent clerk named Albert Einstein, yes, that Einstein, published a scientific paper that would change everything we understood about the universe. He was working in a patent office in Bern, Switzerland. During the day, he examined patent applications. During the night, he was quietly revolutionizing the foundations of physics. Imagine this: a young man, unknown to the scientific community, working a regular job to pay his bills. In his spare time, in the evenings after work, he was solving problems that had puzzled the greatest minds of his generation. He was seeing patterns that no one else had seen. He was asking questions that no one else had thought to ask. This paper explained something called the photoelectric effect. It proved that light arrives in discrete packets, individual units called photons. These are particles of light, tiny bundles of energy. The photoelectric effect is something you can observe yourself. When light hits certain metals, it knocks electrons loose. But here is the strange part. Very dim light will not knock electrons loose, no matter how long you shine it. But even dim light at a higher frequency will knock electrons loose immediately. This makes no sense if light is purely a wave. A wave would build up energy over time, but it makes perfect sense if light comes in particles. Each photon either has enough energy to knock an electron loose, or it does not. The brightness of light tells you how many photons are arriving. The frequency tells you how much energy each individual photon carries. Before Einstein presented this work, most scientists believed that light was purely a wave, similar to ripples moving across the surface of a pond. Einstein showed something different. He demonstrated that light hits metal surfaces like tiny bullets, knocking electrons loose from the metal. This discovery eventually won him the Nobel Prize in 1921. It is worth pausing to appreciate how radical this idea was. For over a century, physicists had been convinced that light was a wave. James Clerk Maxwell had unified electricity and magnetism and shown that light was an electromagnetic wave. This was one of the great triumphs of 19th century physics. And now Einstein was saying that light was also made of particles. He was not rejecting the wave theory, he was adding to it. He was saying reality was stranger than anyone had imagined. But here is where the strangeness truly begins. Those same photons that act like particles also behave exactly like waves. They create interference patterns when they interact with each other. They have wavelengths that can be measured. They can be diffracted, bent around corners like water waves moving around obstacles. Thomas Young proved this wave nature back in 1801 with his famous double-slit experiment. He directed light through two narrow slits and observed what appeared on a screen behind them. The result was an interference pattern, alternating bands of light and darkness. This pattern could only be explained if light was a wave, interfering with itself in some places and reinforcing itself in others. This experiment is so important, so fundamental to our understanding of light, that it is worth describing in more detail. Imagine you have a barrier with two narrow slits cut into it. Behind the barrier, you place a screen that can detect light. Now you shine light at the barrier. If light were simply particles, you would expect to see two bright spots on the screen corresponding to the two slits. But that is not what happens. Instead, you see multiple bands of light and darkness spread across the screen. This is an interference pattern created when waves overlap. Here is what is happening. Light passing through one slit acts like a wave spreading out. Light passing through the other slit also acts like a wave spreading out. These two waves overlap and interfere. Where the peaks of the waves align, you get bright bands. Where a peak meets a trough, they cancel out, creating dark bands. This proves beyond doubt that light is a wave. And yet, when you detect individual photons arriving at the screen, they arrive as discrete particles, as tiny points of light. One by one, they build up the interference pattern. Each photon is a particle, yet the overall pattern is created by wave interference. Think about this for a moment. Imagine that you were simultaneously a solid rock and an ocean wave. You exist as both states at the same time. This is what light is. It represents a fundamental duality woven into the heart of reality itself. This duality is not just a quirk of light. It applies to all quantum particles. Electrons, protons, even entire atoms exhibit wave-particle duality, but light shows it most clearly, most dramatically. Light is the perfect illustration of how quantum mechanics defies our everyday intuitions. Now, these photons, these particles of light, have zero rest mass. This has been confirmed through countless experiments throughout the 20th century and beyond. If photons had even the tiniest, most infinitesimal amount of mass, our entire understanding of the universe would need to be reconstructed. Scientists have tested this with extraordinary precision. If a photon had any mass at all, even an incredibly tiny amount, it would cause measurable effects. Light of different frequencies would travel at slightly different speeds. This would cause the light from distant astronomical events to blur and disperse as it traveled across space. We do not see this. All frequencies of light arrive together, suggesting the photon mass is zero, or at least smaller than we can currently measure. The technology you use every day depends on this fact. GPS satellites orbiting Earth would not function correctly. Your smartphone would become useless. The fact that you can watch this video right now, receiving information transmitted as electromagnetic waves, is proof that photons truly have no mass. GPS is a beautiful example of how fundamental physics affects our daily lives. GPS satellites send out radio signals, which are just photons at a specific frequency. Your phone receives these signals and calculates distances based on how long the signals took to arrive. This calculation assumes that all the signals travel at exactly the same speed, the speed of light. If photons had mass, different signals might travel at slightly different speeds, and GPS would not work. The fact that GPS can pinpoint your location to within a few meters is indirect but powerful proof that photons have no mass. But here is an interesting twist, something that will set up everything else we explore. Just because photons have no rest mass does not mean they have no energy. In fact, photons carry tremendous amounts of energy. This is one of the most subtle and important points in physics. Mass and energy are not the same thing, though they are related. A photon has no mass, yet it has energy. It has momentum. It can exert force. How is this possible? Einstein's most famous equation, E equals mc squared, actually has a more complete form that many people never see. The full equation is E squared equals mc squared squared plus pc squared, where p represents momentum. For a photon with zero mass, this equation simplifies beautifully to E equals pc. Photons possess both energy and momentum, despite having no mass whatsoever. This equation tells us something profound. Energy can exist without mass. Momentum can exist without mass. In the relativistic universe that Einstein revealed to us, energy and momentum are more fundamental than mass itself. For a photon, the energy depends on its frequency. Higher frequency photons, like gamma rays, carry enormous amounts of energy. Lower frequency photons, like radio waves, carry less energy. But all photons, regardless of their energy, travel at the same speed in vacuum. The cosmic speed limit applies equally to all of them. They can push on physical objects. This is why solar sails work in space. Photons streaming from the sun physically push against large reflective surfaces, creating thrust without any fuel. Imagine a spacecraft with enormous reflective sails, perhaps kilometers across. As sunlight strikes these sails, each photon transfers a tiny amount of momentum. Individually, the push from a single photon is impossibly small, but billions upon billions of photons strike the sail every second. Their combined effect creates a measurable force, a gentle but continuous push that can, over time, accelerate the spacecraft to incredible speeds. Japan has actually launched such a spacecraft called Icaros. It successfully demonstrated solar sail propulsion in space. This is not science fiction. This is real technology, powered by the momentum of massless photons. Let me paint a picture for you of just how strange this truly is. Right now, in this moment, photons from the sun are striking your skin. They are massless, yet they are pushing against you. The pressure is unimaginably small, about 9 micronewtons per square meter if you are standing in direct sunlight. But it is real. It is measurable. Massless particles are physically exerting pressure on your body. You are being moved, ever so slightly, by things that have no mass at all. Think about what this means. Every time you feel the warmth of sunlight on your face, you are not just feeling heat, you are also feeling the physical push of photons striking your skin. You are experiencing the momentum of light. The warmth comes from photons transferring their energy to the atoms in your skin, making them vibrate faster. But there is also a physical pressure, a radiation pressure, pushing against you. This pressure is what creates tails on comets. As a comet approaches the sun, the ice on its surface begins to evaporate, creating a cloud of gas and dust. Sunlight pushes this material away from the comet, creating the characteristic tail that always points away from the sun. Comets do not leave a trail behind them as they move. Instead, their tails are pushed ahead of them by the pressure of sunlight. So we have established 2 remarkable facts that seem to contradict our everyday experience. Light is simultaneously a particle and a wave, and it possesses energy and momentum despite having zero mass. These facts alone would be strange enough, but they are just the beginning. They set the stage for an even deeper mystery, one that goes to the heart of what space and time actually are. Now, here is where the real mystery deepens, where most people find their understanding beginning to shift in unexpected ways. If light has no mass, and nothing in the vacuum of space is slowing it down, then why does it move at exactly 299,792,458 meters per second? Why that specific number? Why not 500 million meters per second? Why not an infinite speed? This question has puzzled scientists and philosophers for centuries. Before we knew light had a finite speed, many assumed it traveled infinitely fast. After all, when you light a candle, the room seems to illuminate instantly. There is no perceptible delay. Light seems to jump from the candle to your eyes without taking any time at all. But as our measurements became more precise, we discovered that light does take time to travel. It has a finite, measurable speed. And once we knew that, the question became, why this speed? What determines it? The answer might sound at first like I am avoiding the question, but stay with me, because this is where everything comes together. Light itself does not have a speed limit. the universe does. This is a critical distinction. The speed limit is not a property of photons, it is a property of space-time itself. Light simply reveals this limit to us because light travels at the maximum possible speed. Let me ask you something that might seem unrelated at first. What is space? No, truly. What is the emptiness that exists between objects? Is it simply nothing? A void? An absence of things? For most of human history, people assumed space was simply nothing. Empty space was the absence of matter, the blank stage on which physical events played out. But modern physics has revealed something very different. Space is not nothing. Space is something. It has structure. It has properties. It can bend and warp and ripple. Here is a truth that sounds like it belongs in science fiction, yet it is established fact. Space is something. It is an actual, physical thing. Space has properties, structure, and measurable characteristics. Space can be measured. It has a geometry. In the region of intense gravity, space curves. This curvature is not a metaphor, it is literal. The shortest path between 2 points is no longer a straight line. Space itself has been warped. And here is something even more profound. Space and time are not separate entities. They are woven together into a single, unified fabric that physicists call space-time. Before Einstein, scientists thought of space and time as separate things. Space was the arena in which events occurred. Time was the universal clock that measured when events occurred. They were independent, unrelated concepts. This insight came from Einstein again in 1915 with his general theory of relativity. Einstein realized that what we call space and what we call time are actually two aspects of the same underlying reality. You cannot have space without time. You cannot have time without space. They are fundamentally interconnected, like two sides of the same coin, inseparable and intertwined. Einstein arrived at this insight by thinking deeply about the nature of gravity. Newton had described gravity as a force, an invisible pull between objects with mass. But Newton could not explain how this force worked. How did the sun reach across empty space to pull on the Earth? What was the mechanism? Einstein realized that gravity is not a force at all. Gravity is the curvature of space-time. Massive objects warp the fabric of space-time around them, and other objects follow the curves in this fabric. What we experience as gravity is actually objects following the straightest possible paths through curved space-time. Think of it this way. Imagine a massive rubber sheet stretched tight. This sheet represents space-time. When you place a bowling ball on the rubber sheet, it creates a depression, a curve in the fabric. That curve, that warping of the sheet, is what we experience as gravity. This is more than just an analogy. It is a genuine insight into how gravity actually works. Space-time is flexible. It can be stretched and compressed and curved. And massive objects create curvature in space-time, just as a bowling ball creates a depression in a rubber sheet. Now imagine rolling a marble across the sheet. The marble's path will curve around the depression created by the bowling ball. It will follow the contours of the warped sheet. This is how planets orbit stars, how moons orbit planets, how light itself bends when passing near massive objects. The marble is not being pulled by a force. It is simply following the straightest path available to it through the curved space-time. From the marble's perspective, it is travelling in a straight line. But because space-time itself is curved, that straight line looks curved to an outside observer. Earth orbits the Sun because the Sun's mass warps space-time around it. Earth is simply following a straight path through this curved space-time. That straight path, which physicists call a geodesic, happens to be an ellipse in our ordinary three-dimensional space. Earth is not being pulled toward the sun. Earth is traveling freely through curved space-time. But here is what matters most for our question. That rubber sheet, space-time itself, has intrinsic properties. It is not infinitely stretchy. It has resistance. It has structure and limits. And one of its fundamental properties is that it has a maximum speed at which information, energy, or matter can propagate through it. Space-time has a stiffness, a resistance to change. When you create a disturbance in space-time, perhaps by moving a massive object, that disturbance cannot propagate instantaneously. It spreads outward at a finite speed, and that speed is the cosmic speed limit. That speed is 299,792,458 meters per second. This number is built into the structure of space-time. It emerges from the fundamental constants that govern electromagnetic fields. It is as much a part of the universe as space and time themselves. Light does not travel at the speed of light because of anything special about light itself. Light travels at the speed of light because light has no mass, and anything with no mass automatically travels at the maximum speed that space-time allows. This is worth repeating because it is so important. The speed limit is not about light. The speed limit is about space-time. Light simply reveals this limit to us because photons have no mass, and massless particles automatically travel at the maximum possible speed. The speed of light is actually the speed of causality itself. It is the maximum speed at which cause can lead to effect anywhere in the universe. It is the speed at which reality updates itself moment by moment. Think about what causality means. It means that causes precede effects. It means that events happen in a logical sequence. It means that the past influences the future, but the future does not influence the past. This is the structure that makes reality comprehensible, that makes science possible. The cosmic speed limit enforces this causal structure. It prevents effects from preceding their causes. It maintains the logical flow of time. Without this speed limit, causality would break down, and reality, as we understand it, would become impossible. Let me offer you something that might expand this understanding even further. If we discovered tomorrow that photons actually do have a tiny, tiny amount of mass, so small we cannot currently measure it, then light would travel slightly slower than it does now. But the universal speed limit would remain exactly the same. That limit is a property of space-time itself, not of light. Some theories in physics actually predict that photons might have an extraordinarily tiny mass, far too small to measure with current technology. If this were true, light would travel slightly slower than the cosmic speed limit, but the speed limit itself would remain. Something else, perhaps gravitational waves, would travel at the true cosmic speed limit instead. The point is that the cosmic speed limit is more fundamental than any particular particle. It is a feature of the universe itself. In 1987, astronomers observed something extraordinary. A supernova, an exploding star, appeared in a nearby galaxy called the Large Magellanic Cloud. This galaxy sits about 168,000 light-years away from Earth. Supernovae are among the most violent events in the universe. When a massive star exhausts its fuel, it can no longer support itself against its own gravity. The core collapses in a fraction of a second, releasing more energy than the star produced over its entire multi-million-year lifetime. The outer layers are blown away in a catastrophic explosion that briefly outshines the entire galaxy. This supernova, designated as SN 1987A, released an unimaginable amount of energy in a matter of seconds. Along with visible light, the explosion sent out neutrinos, ghostly particles that barely interact with normal matter. Neutrinos are fascinating particles. They have almost no mass, only the tiniest amount. They do not interact with electromagnetic forces. They can pass through entire planets without being stopped. Trillions of neutrinos from the sun are passing through your body right now, and you do not feel them at all. Both the neutrinos and the photons from the explosion arrived at Earth within hours of each other, despite traveling for 168,000 years across space. This observation told us something profound. Even neutrinos, which might have a tiny amount of mass, travel at nearly the speed of light, and they arrived at almost exactly the same time as the massless photons. This is extraordinary when you think about it. These particles traveled across 168,000 light years of space. That is roughly 1.6 quintillion kilometers. And yet the neutrinos and photons, despite potentially having different masses, arrived within hours of each other. If neutrinos traveled significantly slower than light, they would have arrived days, months, or even years later. But they did not. They arrived almost exactly when the light arrived. This tells us that the cosmic speed limit is not arbitrary. It is a fundamental feature of how particles propagate through spacetime. This suggests that the cosmic speed limit is not about the particles themselves. It is about the structure of spacetime through which they travel. This observation also gave us a direct measurement of neutrino speed across cosmological distances. It confirmed that even massive particles, if they have very little mass, can travel at speeds incredibly close to the cosmic speed limit. Now let us talk about what happens when you try to accelerate something that does have mass. This is where the universe reveals its deeper rules. When you push on an object with mass, trying to make it go faster, something strange happens. The faster it goes, the more energy you need to accelerate it further. This is not because of friction or air resistance. This happens even in the perfect vacuum of space. In our everyday experience, pushing on something makes it speed up at a constant rate. If you double the force, it speeds up twice as fast. This is Newton's second law of motion. Force equals mass times acceleration. It works perfectly for the speeds we normally encounter. But Newton's laws are only an approximation. They work well at slow speeds, but they break down as you approach the speed of light. At high speeds, Einstein's relativity takes over, and the rules change. As an object with mass approaches the speed of light, its resistance to further acceleration grows without limit. The closer you get to light speed, the more energy you need. To actually reach the speed of light with an object that has mass would require infinite energy. Let me give you some numbers to make this concrete. Suppose you want to accelerate a 1 kilogram mass to various speeds. To accelerate it to 10% of light speed requires roughly 4.5 times 10 to the 14th joules of energy. That is about the energy in 100,000 tons of TNT. To accelerate it to 50% of light speed requires about 1.3 times 10 to the 16 joules. To 90% of light speed, about 1.6 times 10 to the 17 joules. The energy required grows rapidly, much faster than you might expect. At 99% of light speed, you need about 4.5 times 10 to the 17 joules. At 99.9%, over 1.4 times 10 to the 18 joules. And as you approach closer and closer to light speed, the energy required continues to grow without limit, approaching infinity, and infinite energy does not exist in our universe. This is why nothing with mass can ever reach the speed of light, let alone exceed it. The universe simply does not permit it. This is not a technological limitation. It is not that we do not have powerful enough rockets or engines. It is a fundamental law of physics. No amount of technology, no matter how advanced, can overcome this limit. The universe will not provide the infinite energy needed to accelerate a massive object to light speed. But here is something wonderful. Light itself, having no mass, does not face this problem. Photons are created already traveling at the cosmic speed limit. They never accelerate. They never slow down in empty space. They simply exist in motion at the maximum speed the universe allows. When an atom emits a photon, the photon instantly travels at light speed. There is no gradual acceleration. The moment the photon exists, it is moving at the cosmic speed limit, and it continues at that speed until it is absorbed by another atom. This is one of the most elegant features of our universe. Massless particles automatically travel at the cosmic speed limit. They do not need to be accelerated. They do not need energy to reach that speed. They simply move at that speed as a consequence of having no mass. Let me share with you something that feels almost like magic, but is completely real. When objects move very fast, approaching the speed of light, time itself begins to behave strangely. This is perhaps the most counterintuitive prediction of special relativity. Time, we assume, flows at the same rate for everyone. 1 second is 1 second, whether you are sitting still or moving. But this assumption is wrong. Time is not absolute. Time is relative. The rate at which time flows depends on how fast you are moving. Imagine two identical clocks. One stays on Earth. The other goes on a journey through space at 90% of light speed. When the traveling clock returns to Earth, less time will have passed for it than for the clock that stayed behind. This is not a malfunction. This is not some quirk of the clock's mechanism. Time itself actually passed more slowly for the moving clock. This effect is called time dilation, and it has been measured countless times. It is not theory, it is observed fact. Time dilation has been tested in many ways. Scientists have taken atomic clocks, the most precise timekeeping devices we have, on airplane flights around the world. When compared to identical clocks that stayed on the ground, the flying clocks showed less elapsed time. The difference is tiny, only a few nanoseconds, but it is real and measurable. Astronauts on the International Space Station age slightly slower than people on Earth. They are moving fast, about 7.7 kilometers per second. At that speed, time dilation is very small, only a few microseconds per day. But over months in space, it adds up. An astronaut who spends a year on the station will age about 0.007 seconds less than someone on Earth. Particles called muons demonstrate this beautifully. Muons are created high in Earth's atmosphere when cosmic rays strike air molecules. These muons are unstable and decay very quickly, with a half-life of only about 2 microseconds. A half-life means that after 2 microseconds, half of the muons will have decayed. After 4 microseconds, 3/4 will have decayed. After 6 microseconds, 7/8 will have decayed, and so on. At the speed muons travel, even moving near light speed, they should decay long before reaching the ground. Simple mathematics tells us they should barely make it a few hundred meters before half of them disappear. Let us do the calculation. Muons typically travel at about 98% of light speed. At that speed, they cover about 294,000 kilometers per second. In their 2 microsecond half-life, they would travel about 600 meters. Maybe a few survive long enough to travel a few kilometers. But the muons are created 20 kilometers high in the atmosphere. By classical physics, almost none of them should reach the ground. They should all decay before getting anywhere near sea level. Yet muons created 20 kilometers high in the atmosphere routinely reach detectors on the ground. How is this possible? The answer is time dilation. From our perspective on the ground, the muons are moving so fast that time slows down for them. Their 2 microsecond half-life stretches out. From the muon's perspective, if a muon could have a perspective, the distance to the ground shrinks because of something called length contraction. Length contraction is the flip side of time dilation. Just as moving clocks run slow, moving rulers are shortened. At 98% of light speed, lengths are contracted by a factor of about 5. So from the muon's perspective, the 20-kilometer journey is only about 4 kilometers. It makes the journey easily within its 2 microsecond lifetime. Either way you look at it, the result is the same. Fast-moving objects experience time differently than stationary objects. Time is not absolute, it is relative. It depends on motion. This is not science fiction. This is experimentally verified. Every particle accelerator in the world routinely observes these effects. Particles circulating at speeds close to light speed live far longer than they should. Their internal clocks run slow compared to the laboratory clocks. And here is something even more striking. Light itself, traveling at the cosmic speed limit, experiences no time at all. From a photon's perspective, if we could somehow ride along with it, the journey from a distant star to your eye happens instantaneously. No time passes for the photon. The moment of its creation and the moment of its absorption are the same moment. This is a profound statement. Let it sink in. A photon emitted by a star 13 billion light years away travels for 13 billion years from our perspective. But from the photon's perspective, no time passes at all. The creation and absorption are simultaneous. To a photon, the entire history of its journey, whether it lasts 1 nanosecond or 13 billion years, occurs in a single, timeless instant. This means that in a very real sense, photons exist outside of time. They do not experience duration. They do not age. They exist in an eternal now. The universe looks very different depending on how fast you are moving through it. This is one of the deepest insights of relativity. There is no absolute time. There is no universal now. Different observers, moving at different speeds, will disagree about what events are simultaneous, about how much time has elapsed, even about the order in which some events occurred. And yet, despite these differences, all observers agree on the laws of physics. All observers measure the same speed of light. The universe maintains its coherence even though time and space are flexible. Now let us explore what would happen if you could travel at light speed. Imagine, just for a moment, that you could somehow accelerate yourself to the cosmic speed limit. This is a thought experiment. We know you cannot actually do this if you have mass, but imagining what would happen helps us understand the nature of space-time. First, time would stop for you completely. You would not age. You would not experience the passage of time at all. The moment you reached light speed and the moment you slowed down again would be the same moment for you, no matter how much time passed in the rest of the universe. If you could travel at light speed from Earth to a star 10 light years away, the journey would take 10 years from Earth's perspective. But from your perspective, the journey would be instantaneous. You would experience no time passing at all. Second, the universe in the direction you are traveling would appear to collapse. Distances would shrink to zero. In your frame of reference, you would arrive at your destination instantly, no matter how far away it was. Length contraction becomes infinite at light speed. The entire universe in front of you would compress to a single point. From your perspective, everything ahead of you would be at zero distance. Third, the universe behind you would appear frozen in time, while the universe ahead of you would seem to rush through billions of years in an instant. Light from behind you would be infinitely redshifted, stretched to infinite wavelength. Light from ahead of you would be infinitely blue-shifted, compressed to infinite frequency. The normal spectrum of light would be completely distorted. But here is the fundamental truth. You cannot actually do this. If you have mass, the universe will not allow you to reach light speed. The laws of physics prevent it absolutely. The universe protects the cosmic speed limit. As you approach light speed, your mass effectively increases. You become harder and harder to accelerate. The energy required grows without limit. The universe ensures that nothing with mass can ever quite reach the speed limit. This brings us to one of the most profound insights in all of physics. The speed of light is the speed at which time stops. It is the boundary between having a future and past and existing in a single eternal moment. Moving through space and moving through time are not separate things. They are connected. The faster you move through space, the slower you move through time. Everything is always moving through space-time at the same total speed, the speed of light. You can trade motion through space for motion through time, but you cannot exceed the total speed limit. Let us think about energy for a moment. When you accelerate an object, you give it kinetic energy. The faster it moves, the more kinetic energy it has. For slow speeds, the relationship is simple. Kinetic energy equals 1/2 times mass times velocity squared. Double the speed and you quadruple the energy. This is the classical physics we learn in school, described by Newton's laws. But as speeds approach light speed, Einstein's relativity takes over. The energy required to accelerate an object grows faster and faster. At 90% of light speed, you need more than twice as much energy as classical physics would predict. At 99% of light speed, the energy required is more than 7 times the classical prediction. Let me give you the actual numbers for a 1 kilogram mass. To accelerate it to 50% of light speed requires about 1.3 times 10 to the 16th joules, compared to the classical prediction of 5.6 times 10 to the 15 joules. Already, reality requires more than twice the energy that Newton's equations would suggest. At 99.99% of light speed, the required energy becomes enormous, more than 70 times what Newton's equations would suggest. The relativistic mass increases without limit as you approach light speed. Your effective mass becomes larger and larger, requiring more and more energy to accelerate further. This continues without limit. As you approach light speed, the energy required approaches infinity. You cannot actually get there because infinite energy does not exist. This is not a technological limitation. This is not something we might overcome with better engines or more advanced science. This is a fundamental law woven into the structure of the universe itself. The cosmic speed limit exists because the universe will not provide infinite energy to anything with mass. In a very real sense, the speed limit is enforced by the conservation of energy. The universe has a finite amount of energy. It cannot provide infinite energy to accelerate something to light speed. Now, here is something that will shift your perspective. Mass and energy are not separate things. They are two forms of the same underlying reality. Einstein showed us this with E equals mc squared. This equation tells us that mass can be converted into energy. Energy can be converted into mass. They are equivalent, two sides of the same coin. Every time you feel heat, you are experiencing the equivalence of mass and energy. Heat is the kinetic energy of atoms vibrating, but this kinetic energy contributes to the mass of the object. A hot object weighs slightly more than a cold object, though the difference is far too small to measure in everyday situations. When you accelerate an object, you are adding energy to it. That energy increases the object's inertia, its resistance to further acceleration. In a very real sense, The added energy behaves like added mass. The faster something moves, the more energy it contains, and the more it resists further acceleration. This is why reaching light speed requires infinite energy. You would be trying to add infinite energy to the object, which would make it infinitely resistant to further acceleration. At rest, an object has its rest mass, the mass you would measure if you weighed it on a scale. But as it moves, it gains kinetic energy, and this energy contributes to its inertia. Physicists sometimes call this relativistic mass. The faster something moves, the larger its relativistic mass becomes. This is not just a mathematical trick. It has real physical consequences. The object becomes harder to accelerate. It interacts more strongly with gravitational fields. Its momentum becomes larger than classical physics would predict. Light escapes this trap because photons have no rest mass. They are pure energy from the beginning. They never need to be accelerated. They exist in motion at the cosmic speed limit from the moment they are created. A photon's energy depends on its frequency. A high-frequency photon, like a gamma ray, has a lot of energy. A low-frequency photon, like a radio wave, has less energy. But both travel at the same speed. The speed of light, the cosmic speed limit, applies equally to all photons. Let me share something beautiful about the geometry of the universe. In our everyday experience, we measure distances using 3 dimensions: length, width, and height. And we measure time as something separate. We live in 3-dimensional space. We can move forward and backward, left and right, up and down. These are the 3 spatial dimensions. Time is different. We move through time in only one direction, from past to future. We cannot move backward in time. We cannot stand still in time. But in Einstein's relativity, space and time merge into a 4-dimensional space-time. In this 4-dimensional universe, there is a quantity that remains constant for all observers, no matter how they are moving. Physicists call this the space-time interval. The space-time interval is a measure of the distance between 2 events in 4-dimensional space-time. It combines spatial distance and temporal duration in a specific way. Different observers will disagree about the spatial distance between 2 events and the time elapsed between them, but they will all agree on the space-time interval. This is analogous to how everyone agrees on distances in 3-dimensional space, even if they use different coordinate systems. If you rotate your perspective, north becomes northeast, east becomes southeast, and so on. But the actual distance between 2 points does not change. It is the same, regardless of your orientation. In space-time, different observers are like different orientations. They disagree about space and time separately, but agree on the combined space-time interval. When you move through space, you also move through time. In fact, everything is always moving through space-time at exactly the same total speed, the speed of light. This is an extraordinary insight. Right now, sitting still, you are moving through time at the maximum possible rate. Every second, you age by 1 second. You are traveling through time at 1 second per second. Think of it this way. You have a fixed total velocity through 4-dimensional space-time. When you sit still in space, you are moving through time at maximum speed. Time passes normally for you. When you move through space, some of your motion through time converts into motion through space. The faster you move through space, the slower you move through time. This is why moving clocks run slow. At the cosmic speed limit, all of your motion is through space, with none left for motion through time. This is why time stops at light speed. Light itself moves through space at the maximum possible speed. This means all of its motion is through space, with none left for motion through time. light does not experience time at all. You are always moving through space-time at light speed. But you can trade motion through space for motion through time, or vice versa. You cannot exceed the total speed limit, which is the speed of light. This is one of the most elegant insights in all of physics. The cosmic speed limit is not just a limit on motion through space, it is a limit on motion through space-time itself. You are always moving at light speed through space-time. Always. Right now. Forever. You cannot move faster or slower through space-time. You can only change the balance between your motion through space and your motion through time. Now let us talk about what light speed means for causality, for the relationship between cause and effect. Causality is the principle that effects follow causes, that events happen in a logical sequence, that the past influences the future, but the future does not influence the past. This seems obvious, but it is actually a profound principle that structures our entire understanding of reality. Imagine you are standing on Earth and your friend is standing on Mars. Mars is, on average, about 12.5 light minutes away. This means light takes 12.5 minutes to travel from Earth to Mars. If you send a light signal to your friend on Mars, there is no way for that signal to arrive in less than 12.5 minutes. No matter what technology you use, no matter what method you employ, the signal cannot get there faster because nothing can travel faster than light. This means that for 12.5 minutes, there is no way for you to affect what happens on Mars. Your actions on Earth cannot influence events on Mars until at least 12.5 minutes have passed. During those 12.5 minutes, you and your friend on Mars are causally disconnected. Nothing you do can affect them, nothing they do can affect you. You exist in separate causal worlds until enough time has passed for light to travel between you. This creates a structure to causality. Events have a past light cone, all the events that could have influenced them, and a future light cone, all the events they could potentially influence. The past light cone of an event consists of all the points in space-time that could have sent a signal, travelling at light speed or slower, that would reach the event. These are all the events that could potentially have caused or influenced the event you are considering. The future light cone consists of all the points in space-time that could be reached by a signal travelling at light speed or slower from the event. These are all the events that could potentially be caused or influenced by the event you are considering. Events outside your light cone cannot affect you and cannot be affected by you. They are causally disconnected from you. The cosmic speed limit ensures that causality flows in a coherent way. Effects cannot precede their causes. The universe maintains a logical, ordered structure to the flow of events. Without this speed limit, causality would break down. You could potentially affect the past. Effect could precede cause. The universe would lose its logical structure. Reality as we understand it would become impossible. Imagine if information could travel infinitely fast. Then every event in the universe would be simultaneous with every other event. There would be no past or future, only an eternal now. Cause and effect would lose their meaning. How could causes precede effects if everything happened at the same time? The speed of light is not just a speed limit. It is a causality limit. It is what makes time flow in a consistent direction and what prevents paradoxes from tearing reality apart. The finite speed of causality creates the possibility of free will. Your decisions now cannot instantly affect the entire universe. They propagate outward at light speed, creating an expanding sphere of influence. This means there is a genuine openness to the future, a realm of possibility that has not yet been determined. Let me share something that might surprise you. The speed of light is the same for all observers, regardless of how fast they are moving. This is perhaps the single strangest fact in all of physics. It is also the most fundamental postulate of special relativity, and it has been tested thousands upon thousands of times. It is absolutely, certainly true. This sounds impossible. If you are on a train moving at 100 kilometers per hour and you throw a ball forward at 20 kilometers per hour, someone standing beside the tracks would measure the ball moving at 120 kilometers per hour. The speeds add up. This is how velocities work in everyday life. If something is moving and you throw something forward from it, the speeds add. This is called Galilean relativity, and it works perfectly for the slow speeds we normally encounter. But light does not work this way. If you shine a flashlight forward while traveling at 90% of light speed, you would measure the light leaving your flashlight at exactly light speed. And someone at rest would also measure that same light beam traveling at exactly light speed, not at 1.9 times light speed, just light speed. The speeds do not add. Light travels at the same speed relative to every observer, regardless of how they are moving. This seems to violate common sense. It seems to violate logic. How can both observers measure the same speed for the light beam when they are moving relative to each other? But it has been tested thousands of times. It is absolutely true. In the early 1900s, physicists performed increasingly precise experiments to try to measure how Earth's motion affected the speed of light. They expected to find that light traveled faster when moving with Earth's motion and slower when moving against it. They found nothing. Light speed was the same in all directions, regardless of Earth's motion through space. The most famous of these experiments was performed by Albert Michelson and Edward Morley in 1887. They built an extraordinarily sensitive device called an interferometer that could detect incredibly tiny differences in light speed. They found no difference. Light traveled at the same speed in all directions. This null result was initially puzzling and disturbing. It seemed to violate everything physicists thought they understood about motion and velocity. This constancy of light speed is what leads to time dilation and length contraction. The universe adjusts time and space to ensure that light speed remains constant for everyone. Think about how profound this is. The universe literally warps time and space around you to ensure that light always travels at the same speed from your perspective. If you are traveling at 90% of light speed and you shine a flashlight forward, the light moves away from you at light speed. How is this possible? How can the light only be moving 10% faster than you are, yet still be traveling at full light speed? The answer is that time slows down for you and distances contract for you. From your perspective, you are at rest and the universe is moving past you at 90% of light speed. Light leaving your flashlight travels at light speed relative to you. Meanwhile, time in the rest of the universe is passing faster and distances in the rest of the universe are expanded. The mathematics works out perfectly. Everyone measures the same speed of light, but they disagree about time and distance. The universe adjusts time and space as needed to maintain the constancy of light speed. Light speed is more fundamental than time or space individually. The universe will bend time and space as needed to preserve the constancy of light speed. This tells us something profound about the nature of reality. Light speed is not just a speed. It is a fundamental constant that structures space-time itself. Time and space are flexible, adjustable, relative, but the speed of light is absolute. It is the same for all observers in all situations. In a sense, the speed of light is more real than time or space themselves. Now, let me tell you about something that stretches at the very edges of physics. While nothing can travel through space faster than light, space itself can expand faster than light. This sounds like a contradiction. How can the universe have a speed limit and yet space itself can expand faster than that limit? The key is the distinction between motion through space and the expansion of space itself. Objects cannot move through space faster than light, but space itself can grow, and this growth is not limited by the cosmic speed limit. In the very early universe, a fraction of a second after the Big Bang, space expanded exponentially fast in a period called inflation. During this brief moment, lasting perhaps 10 to the negative 32 seconds, the universe grew by a factor of at least 10 to the 26th. In a fraction of a second, the universe went from smaller than an atom to larger than a galaxy. Regions of space that started out touching each other were suddenly separated by vast distances, far too large for light to cross in the time that had elapsed. During this inflationary period, regions of space moved apart from each other faster than light, but nothing actually moved through space faster than light. Instead, new space was being created between objects, carrying them apart. This does not violate relativity because space itself was expanding. Objects were not moving through space faster than light. Rather, new space was being created between objects, carrying them apart. Think of it like dots on a balloon. As you inflate the balloon, the dots move apart from each other. But the dots are not moving across the surface of the balloon. The surface itself is expanding, carrying the dots with it. Even today, the universe continues to expand. Distant galaxies are moving away from us, not because they are traveling through space, but because space between us and them is growing. The most distant galaxies are receding faster than light speed, carried away by the expansion of space itself. In fact, most of the observable universe is receding from us faster than light. Any galaxy more than about 14 billion light-years away is currently receding faster than light speed. Light from these galaxies can never reach us, no matter how long we wait. They are beyond what we call the cosmic horizon. They are forever outside the observable universe. This is a profound limitation. There are galaxies out there, countless billions of them, that we will never be able to see. Their light will never reach us because space is expanding too fast between us and them. In fact, the observable universe is a sphere about 93 billion light-years in diameter, but the actual universe is almost certainly much larger, perhaps infinitely large. Most of the universe is forever beyond our view, hidden beyond the cosmic horizon. This expansion of space does not violate the cosmic speed limit because nothing is actually moving through space faster than light. Space itself is growing. This is a subtle but crucial distinction. The cosmic speed limit applies to motion through space, not to the expansion of space itself. In a sense, space does not care about the speed limit. Only objects moving through space must respect the limit. Let me share something beautiful about particles that do have mass. There is a special speed for each particle, a speed at which it naturally moves if no forces act on it. Actually, this is not quite right. Particles with mass do not have a single natural speed. Their speed depends on how much energy they have, but there is a relationship between energy and speed that is characteristic for each type of particle. For photons, which have no mass, this natural speed is exactly light speed. Photons always travel at the cosmic speed limit when moving through vacuum. No matter what their energy, no matter what their frequency, all photons in vacuum travel at the same speed. A low-energy radio photon and a high-energy gamma-ray photon both travel at exactly light speed. For particles with mass, their natural speed is slower than light speed. The more mass a particle has, the more energy is required to accelerate it to any given speed. Electrons, being very light, can be accelerated to speeds very close to light speed, with relatively little energy. Protons, being nearly 2,000 times heavier, require much more energy to reach similar speeds. But no matter how much energy you give to a massive particle, it will always travel slower than light. The cosmic speed limit remains forever out of reach. In particle accelerators, physicists routinely accelerate particles to speeds exceeding 99.99% of light speed. At the Large Hadron Collider, protons are accelerated to 99.999991% of light speed. At that speed, each proton has over 7,000 times its rest mass in energy. The protons are moving so fast that their relativistic mass is 7,000 times their rest mass. They become incredibly difficult to accelerate further. To reach these speeds, the Large Hadron Collider uses superconducting magnets and electric fields extending over a 27-kilometer ring. The protons go around this ring over 11,000 times per second, gaining energy with each pass until they reach their final tremendous speed. Yet even at this incredible speed, they are still not quite traveling at light speed. They are traveling at 99.999991% of light speed. The final fraction of a percent is unreachable, protected by the cosmic speed limit. Some particles, like neutrinos, have such tiny masses that they travel at speeds extraordinarily close to light speed. Neutrinos have masses less than 1/millionth the mass of an electron. At typical neutrino energies, they travel at speeds differing from light speed by only a few parts in a million. But even neutrinos, as close as they get, never quite reach the limit. When neutrinos were first discovered, physicists thought they might have zero mass, like photons. If that were true, they would travel at exactly light speed. But later experiments showed that neutrinos do have a tiny bit of mass, and therefore must travel slightly slower than light. The cosmic speed limit stands absolute. It is not a barrier to be broken. It is a fundamental law woven into the fabric of reality itself. No particle with mass, no matter how tiny that mass, can quite reach light speed. The universe enforces this rule without exception. There are no loopholes, there are no workarounds. The cosmic speed limit is absolute. Now let us talk about what this means for information. Information cannot travel faster than light. This is a fundamental principle of physics. Information is a subtle concept. It is not the same as matter or energy, though it is always carried by matter or energy. Information is the answer to a question, the resolution of uncertainty, the specification of which possibility is actual. When you send a message, whether it is a radio signal, a beam of light, or even a gravitational wave, that message propagates outward at the speed of light or slower. Nothing can carry information faster. This has profound implications. It means there is no such thing as instantaneous communication across distances. It means the universe cannot be perfectly synchronized. It means there is always a delay between cause and effect for spatially separated events. When you make a phone call across the planet, there is a delay. For a wired connection, the delay is typically around 100 to 200 milliseconds, about a tenth of a second. For a satellite connection, the delay can be half a second or more. These delays arise because the signals carrying your voice must travel across vast distances, and they cannot travel faster than light. When astronauts on the Moon talked to mission control on Earth, there was a noticeable delay of over 2.5 seconds round trip. 1.25 seconds for the signal to travel from Earth to Moon, and another 1.25 seconds for the response to return. Some people wonder about quantum entanglement, where measuring one particle instantly affects another particle, no matter how far away. Does this allow faster than light communication? The answer is no. While entanglement creates correlations between distant particles, you cannot use these correlations to send information faster than light. The details are subtle, but the conclusion is firm. Quantum mechanics, strange as it is, still respects the cosmic speed limit. When you measure one particle of an entangled pair, it instantly takes on a definite state, and the other particle instantly takes on the corresponding state. This happens even if the particles are light years apart. This seems to involve instantaneous action at a distance, apparently violating the cosmic speed limit. But you cannot use this to send information. The state of each particle appears random when you measure it. Only when you compare the measurements of both particles do you see the correlation. And comparing the measurements requires sending classical information which cannot travel faster than light. So entanglement does not allow faster than light communication. It creates correlations, but not causation. The cosmic speed limit is maintained. Information, cause and effect, influence, all of these travel at light speed or slower, never faster. The universe maintains this rule without exception. This prohibition on faster than light information has deep connections to causality and the structure of time. If you could send information faster than light, you could, in principle, send information into your own past, creating paradoxes. The universe prevents this by forbidding faster than light information transfer. Let me paint a picture of just how fundamental this speed limit is. When you flip a light switch, the electrical signal travels down the wire at a speed slower than light, but still very fast, typically 50 to 99% of light speed, depending on the wire. The speed depends on the properties of the wire and the insulation around it. In a typical household wire, electrical signals travel at about 2/3 the speed of light, about 200 million meters per second. The electricity does not flow instantly. There is a tiny but real delay between flipping the switch and the light turning on. For normal distances in your home, this delay is far too short to notice, only a few nanoseconds. But it is there. It is real. If you had a wire stretching from Earth to the Moon, and you flipped a switch on Earth, it would take over a second for the signal to reach the other end. The people on the Moon would not see the effect of your action until more than a second after you flip the switch. It does not travel instantaneously. This was an extraordinary insight. From observations of Jupiter's moon, using only the technology of the late 1600s, Römer had discovered one of the fundamental constants of nature. His calculation was correct in principle, though not in precision. Light does take time to cross the solar system. When Jupiter is on the opposite side of the Sun from Earth, about 5 astronomical units away, light takes about 40 minutes to travel from Jupiter to Earth. Over the following centuries, scientists refined measurements of light speed. In the 1840s, Hippolyte Fizeau measured light speed using a rotating toothed wheel. Light passed through gaps in the wheel, travelled several kilometers to a mirror, and returned. By spinning the wheel fast enough, he could block the returning light with the next tooth. From the speed of rotation and the distance travelled, he calculated the speed of light to within 5% of the true value. In the 1860s, James Clerk Maxwell developed his equations describing electricity and magnetism. These equations unified the two phenomena, showing they were different aspects of the same underlying electromagnetic field. When Maxwell solved his equations, he found they predicted a wave that travelled through space. This wave consisted of oscillating electric and magnetic fields, each creating the other, propagating through space in a self-sustaining manner. The equations predicted a specific speed for these electromagnetic waves. When Maxwell calculated this speed from fundamental constants describing electric and magnetic fields, he got approximately 300 million meters per second. That speed matched the measured speed of light. Maxwell realized that light was an electromagnetic wave. Visible light, radio waves, X-rays, all were electromagnetic waves, differing only in frequency, and the speed of light fell naturally out of the fundamental properties of electric and magnetic fields. It was determined by two constants: the permittivity of free space, describing how electric fields behave, and the permeability of free space, describing how magnetic fields behave. This was a profound unification. Light, electricity, and magnetism were all aspects of the same underlying phenomenon, and the speed of light was determined by fundamental constants of nature. In the late 1800s, Albert Michelson developed increasingly precise methods to measure light speed. In 1879, he measured light speed to an accuracy better than 1 part in 1,000. Over subsequent decades, he continued to refine his measurements. In the early 20th century, Michelson and Edward Morley performed a famous experiment trying to measure how Earth's motion affected the speed of light. Scientists at the time believed that light travelled through a medium called the luminiferous ether. They expected that Earth's motion through the ether would create an ether wind affecting the speed of light in different directions. Michelson and Morley built an extraordinarily sensitive interferometer to detect this ether wind. They could measure differences in light speed, smaller than 1 part in 100 million. They found nothing. Light speed was the same in all directions, regardless of Earth's motion through space. They tried the experiment at different times of year, when Earth was moving in different directions. Still nothing. Light speed remained constant. They repeated the experiment with ever greater precision. Always the same result. No ether wind. No variation in light speed. This null result was initially puzzling and disturbing. It seemed to contradict what physicists thought they understood about waves and motion. How could light speed be unaffected by Earth's motion? Some physicists proposed ad hoc explanations. Maybe Earth dragged the ether along with it. Maybe moving objects contracted just enough to cancel out the effect. But the true explanation was far more radical. It came from Einstein in 1905 with special relativity. Einstein explained it with special relativity. Light speed is constant for all observers. It does not depend on the motion of the source or the observer. This constancy is built into the structure of space-time itself. Space and time are not absolute. They are relative. They adjust themselves to ensure that light speed remains constant for all observers. This was the revolutionary insight that explained the Michelson-Morley result. The null result was not a failure. It was a profound success. It revealed one of the deepest truths about the universe, that light speed is more fundamental than space and time themselves. Today, the speed of light is defined to be exactly 299,792,458 meters per second. This is not measured anymore, it is defined. We use it to define what a meter is. In 1983, the International Bureau of Weights and Measures redefined the meter based on the speed of light. 1 meter is now defined as the distance light travels in vacuum in exactly 1,299,792,458 of a second. The second is defined by atomic clocks, measuring the oscillation of cesium atoms. And the meter is defined by the distance light travels in a defined fraction of a second. This means the speed of light is now exact by definition. It has no uncertainty. It is exactly 299,792,458 meters per second, because that is how we define the meter. The cosmic speed limit has become one of the most precisely known constants in all of physics, and it serves as the foundation for our definitions of distance and time. This is appropriate because light speed is more fundamental than meters or seconds. It is a property of space-time itself, while meters and seconds are human inventions, arbitrary units we use for convenience. Let me share something about what happens at a black hole, where gravity becomes so strong that even light cannot escape. Black holes are among the strangest objects in the universe. They are regions where space-time is curved so severely that nothing, not even light, can escape from inside a certain boundary. The surface of a black hole, called the event horizon, is defined as the place where the escape velocity equals the speed of light. Inside the event horizon, you would need to travel faster than light to escape. And since nothing can travel faster than light, nothing can escape. This makes black holes truly black. Light that falls past the event horizon cannot come back out. The black hole becomes a one-way membrane in space-time. Things can fall in, but nothing can come out. At the event horizon itself, something strange happens. Time dilation becomes extreme. For someone watching from a safe distance, time appears to stop at the event horizon. An object falling toward a black hole appears to slow down, becoming frozen in time as it approaches the horizon. From a distance, you would see the object take forever to actually reach the horizon. It would get closer and closer, slower and slower, asymptotically approaching but never quite reaching the horizon. Its light would be increasingly redshifted until it faded from view completely. But from the perspective of the falling object, nothing special happens at the horizon. Time continues normally. The object falls through the horizon in finite time and continues toward the center. For a large black hole, millions of times the mass of the Sun, you would not even feel any unusual forces as you crossed the horizon. You would not know you had crossed the point of no return. This difference in perspectives arises because of the extreme warping of space-time near the black hole. The cosmic speed limit, combined with intense gravity, creates this strange behavior. Inside the black hole, space-time is warped so severely that all paths lead inward toward the center. Even light, traveling at the cosmic speed limit, cannot escape. The future direction of time itself points toward the center of the black hole. In a very real sense, inside the black hole, moving toward the center is not moving through space. It is moving forward in time. Falling toward the center is as inevitable as moving from past to future. You cannot avoid it any more than you can avoid tomorrow becoming today. The center of the black hole is called a singularity. According to general relativity, matter at the center is compressed to infinite density, creating a point where the curvature of space-time becomes infinite. At the singularity, our equations break down. We cannot predict what happens there. Most physicists believe that quantum effects, not yet fully understood, prevent the formation of true singularities. Some theory of quantum gravity, combining quantum mechanics and general relativity, will replace the singularity with something else, some quantum state where matter and space-time behave in ways we do not yet understand. But whatever happens at the center, the event horizon remains. The cosmic speed limit ensures that black holes are black, that information cannot escape once it falls past the horizon. Black holes reveal the cosmic speed limit at its most extreme, showing us what happens when gravity becomes strong enough that not even light can outrun it. Now let me tell you something that connects the cosmic speed limit to the very beginning of the universe. In the first moments after the Big Bang, the universe was incredibly hot and dense. Temperatures were billions of degrees. Matter existed as a plasma of fundamental particles, far too hot for atoms to form. Light could not travel freely through this plasma. Photons constantly collided with charged particles, scattering in all directions, absorbed and re-emitted over and over again. The universe was opaque to light, like trying to see through thick fog. You could not see more than a tiny distance before the light scattered. This state persisted for hundreds of thousands of years. The universe expanded and cooled, but it remained a glowing fog, with photons trapped in a constant dance with matter. About 380,000 years after the Big Bang, the universe cooled enough for neutral atoms to form. Electrons combined with nuclei to form hydrogen and helium atoms. Suddenly, photons could travel freely through space. The universe became transparent. This moment is called recombination. It marks the transition from an opaque plasma to a transparent gas of neutral atoms. The light from this moment has been travelling through space ever since, for over 13.7 billion years. We can see it today as the cosmic microwave background radiation, a faint glow coming from all directions in the sky. This is the oldest light in the universe. It comes from a shell surrounding us in all directions, showing us what the universe looked like 380,000 years after the Big Bang. The cosmic microwave background has been travelling toward us at exactly the speed of light, never faster, never slower. It carries information about the early universe, frozen in its patterns of temperature variation. These tiny temperature variations, differing by only 1 part in 100,000, are the seeds that grew into all the structure we see today. Regions slightly denser than average collapsed under their own gravity to form galaxies, stars, and planets. Every time we observe the cosmic microwave background, we are seeing light that has been travelling at the cosmic speed limit for almost the entire age of the universe. The cosmic speed limit is not just a law of physics today. It has been in operation since the very beginning of time itself. In fact, the cosmic speed limit helped determine how the early universe evolved. The speed at which information could propagate determined how quickly different regions could influence each other, how quickly structure could form, how quickly the universe could organize itself. If the cosmic speed limit had been different, the universe would have evolved differently. A faster speed limit would have allowed the early universe to smooth out more quickly, perhaps preventing the formation of galaxies. A slower speed limit would have changed how quickly gravity could pull matter together, altering the timeline of structure formation. The cosmic speed limit we observe appears to be calibrated, along with other fundamental constants, in a way that allows the universe to develop interesting structure, to form stars and planets, and eventually life. Let me share something about how the cosmic speed limit creates the possibility of history. Because information cannot travel infinitely fast, the universe has a past, present, and future that are meaningfully distinct. Events that happened far away in the past are part of our history because their light has had time to reach us. Events happening right now in distant galaxies are not yet part of our present because their light has not yet arrived. When you look at the night sky, you are looking back in time. The light from the nearest star, Proxima Centauri, left that star 4.2 years ago. The light from the Andromeda Galaxy left 2.5 million years ago. The light from the most distant galaxies we can see left over 13 billion years ago, when the universe was young. The finite speed of light creates a temporal structure to the universe. It creates the possibility of history, of change unfolding over time, of cause preceding effect in a coherent, logical way. If information travelled infinitely fast, the entire universe would be in instantaneous contact with itself. Everything would happen at once. There would be no meaningful distinction between past, present, and future. Events separated in space would still be simultaneous. The universe would exist as a timeless whole, with all of history coexisting in a single eternal moment. The cosmic speed limit creates time itself as we experience it. It creates the flow from past to future. It creates the possibility of change, of evolution, of narrative. History requires time, and time, in the sense of a flow from past to future, requires a finite speed for causality. If causes could instantly affect the entire universe, there would be no flow of time, no unfolding of events, no history. You exist in a universe that has a history because the cosmic speed limit prevents everything from happening at once. Every memory you have exists because of the structure of causality enforced by the cosmic speed limit. Your past is real because events have an order, because causes precede effects, because time flows in a consistent direction from past to future. Now, let me tell you something about why the speed of light has the value it does. Why 299,792,458 meters per second? Why not some other number? The honest answer is that we do not fully know. The speed of light emerges from two fundamental constants: the permeability of free space, denoted μ0, and the permittivity of free space, denoted ε0. These relate to how electric and magnetic fields behave in vacuum. The permeability describes how strongly magnetic fields are generated by electric currents. The permittivity describes how electric fields interact with charges and how much energy they can store. The speed of light equals 1 divided by the square root of the product of permeability and permittivity. This relationship comes directly from Maxwell's equations describing electromagnetism. C equals 1 over the square root of μ0 times ε0. But this just pushes the question back a level. Why do the permeability and permittivity have the values they do? We do not know. They appear to be fundamental properties of our universe, not derived from anything deeper that we currently understand. These constants determine not just light speed, but all of electromagnetism. They affect how charges interact, how strong electromagnetic forces are, how electromagnetic waves propagate. All of chemistry depends on these constants, because chemistry is fundamentally about electromagnetic interactions between atoms. Some physicists speculate that these values might be different in other universes if other universes exist. This is the idea of the multiverse. If there are many universes, each might have different values for its fundamental constants. In some of those universes, the cosmic speed limit might be higher or lower. In universes where it is much higher, conditions would be very different. The early universe might have evolved in dramatically different ways. In universes where the speed limit is much higher, perhaps millions or billions of times faster than in our universe, causality would spread much more quickly. The early universe would reach equilibrium faster. Small density fluctuations might smooth out before they could grow into galaxies. In universes where it is much lower, physics would be dramatically different. Chemistry as we know it might not be possible. The behavior of atoms and molecules depends sensitively on the strength of electromagnetic forces, which depends on these fundamental constants. If the cosmic speed limit were much slower, reactions would happen differently. Stars might not be able to shine. Nuclear fusion in stellar cores requires precise balances of forces that depend on these constants. Our universe, with its specific cosmic speed limit of about 300 million meters per second, appears to be calibrated in a way that allows complex structures like stars, planets, and life to exist. Whether this is coincidence, necessity, or something else entirely, whether there is some deeper reason why the constants have the values they do, remains one of the great open questions in physics. Some physicists propose anthropic reasoning. We observe these values because only universes with these values can support observers like us. We exist in a universe compatible with our existence, which is a tautology but might still be a meaningful constraint. Others seek deeper explanations. Perhaps a theory of quantum gravity will reveal why the constants must have the values they do. Perhaps string theory or some other framework will derive them from deeper principles. Or perhaps they truly are arbitrary, determined by random processes in the very early universe. We do not yet know. This is one of the deepest questions in physics, one that connects cosmology, particle physics, and fundamental theory. Let me share a story that has been unfolding across billions of years, a story in which you play a part. You are woven into the fabric of this cosmic narrative. The atoms in your body were forged inside stars that died long before Earth existed. Every atom, heavier than hydrogen and helium, was created in the core of a star or in a supernova explosion. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, all were created by nuclear fusion in stars that lived and died billions of years ago. When those stars exploded as supernovae, they scattered their atoms into space. The explosion created a shockwave, travelling outward at thousands of kilometers per second. But information about the explosion could only travel at light speed. Those atoms drifted through the galaxy for millions or billions of years. Eventually, about 4.6 billion years ago, they became part of a cloud of gas and dust that began to collapse under its own gravity. This collapse formed our solar system. The sun ignited at the center. Planets formed from the disk of material orbiting the sun. Earth formed from countless collisions of smaller bodies, gradually sweeping up material in its orbital path. Throughout this entire journey, light traveled at the cosmic speed limit. Photons from distant stars carried energy across the galaxy. Some of those photons were absorbed by the cloud that formed our solar system, transferring energy, driving chemical reactions, creating complexity. Some of those photons were absorbed by early Earth billions of years ago. They drove photosynthesis in primitive organisms, creating the oxygen atmosphere that now allows complex life like us to exist. Other photons carried energy that powered the chemical reactions that led to the emergence of life, to the first self-replicating molecules, to the long, slow process of evolution that eventually led to you. You exist because light travels at the speed it does, not faster, not slower. The cosmic speed limit is calibrated precisely to allow structures like stars, planets, and living things to form and persist. If the speed of light were much faster, perhaps 10 or 100 times faster, the early universe would have evolved differently. Density fluctuations would have smoothed out more quickly. The intense heat of the Big Bang would have spread more evenly. Small variations in density might not have grown into the large-scale structure of galaxies and clusters we see today. Matter would not have clumped efficiently into galaxies and stars. Without galaxies and stars, there would be no place for heavy elements to form, no planets, no life. If the speed of light were much slower, perhaps 1,000 times slower, the universe would have evolved differently in other ways. Stars might not have been able to form or shine as they do. The balance of forces in stellar cores depends on how quickly energy can flow outward, which is limited by the speed of light. Photons created in the core of the sun take tens of thousands of years to random walk to the surface because they are constantly absorbed and re-emitted by atoms in the dense solar interior. If light speed was slower, this process would take even longer. Stars might collapse under their own gravity before energy could escape. The physics of atoms and molecules would be different. Chemical bonds depend on electromagnetic interactions between electrons and nuclei. The strength of these interactions depends on fundamental constants, including those that determine light speed. The speed limit we observe about 300 million meters per second, appears to be compatible, perhaps not coincidentally, with the existence of complexity and life. The universe has unfolded over 13.7 billion years in a way that led to you. The cosmic speed limit has shaped every step of that journey. Let me share the final, most profound insight. The speed of light is the speed of reality itself. When physicists talk about the speed of light, we are not really talking about light. We are talking about the maximum speed at which cause can propagate to effect. We are talking about the speed at which reality updates itself, computing each moment from the previous moment. We are talking about the fundamental tempo at which existence unfolds. Light just happens to be the most obvious, most visible thing that travels at this speed because light has no mass. But the cosmic speed limit is more fundamental than light itself. It is the speed at which information can propagate through space. It is the speed at which changes in electromagnetic fields spread outward. It is the speed at which gravitational waves travel through space-time. It is the speed at which the Higgs field, the field that gives particles their mass, can communicate changes across space. The speed of light is the heartbeat of the universe. It is the rate at which the cosmos processes information and evolves from one moment to the next, computing reality from the rules of physics. Every interaction, every particle collision, every quantum event propagates outward at this speed, creating an expanding sphere of influence, adding its small effect to the vast web of cause and effect that structures reality. Your actions right now are propagating outward at the speed of light. When you move your hand, you create tiny disturbances in the electromagnetic field around you. The electrons in your skin are charged particles, and moving charged particles create electromagnetic waves. Those disturbances travel outward as electromagnetic waves at the speed of light. They spread in an expanding sphere, growing weaker as they spread out over a larger area, but never disappearing completely. They are incredibly weak, far too weak to detect with any instrument we have. A single hand wave creates electromagnetic waves carrying an almost unimaginably tiny amount of power, far less than a trillionth of a watt. But they are real. They exist. They are part of the electromagnetic field of the universe. You are constantly sending out electromagnetic ripples that travel at the speed of light. Every motion you make, every muscle contraction, every heartbeat, every thought in your brain creates tiny electromagnetic signals that propagate outward at the cosmic speed limit. You are adding your small contribution to the vast symphony of fields and particles that make up reality, a symphony conducted at the tempo of the speed of light. Every atom in your body is held together by electromagnetic forces. The electrons in orbit around nuclei are bound by electromagnetic attraction to the positively charged protons. These forces propagate at light speed. The very structure of matter depends on electromagnetic interactions that propagate at the cosmic speed limit. Every thought in your brain is an electrical signal, a wave of ions moving across neuron membranes, triggering neurotransmitters, cascading through neural networks at speeds ultimately governed by the cosmic speed limit. Your consciousness, your awareness, your ability to read these words and contemplate these ideas all depend on signals propagating through your nervous system. Those signals travel much slower than light speed, only about 100 meters per second for the fastest neurons. But the electromagnetic forces that allow those signals to exist, that hold the molecules together, that make chemistry possible, all propagate at light speed. You are a pattern of information, constantly updating, constantly changing, constantly interacting with your environment, all at rates determined by the fundamental structure of space-time. So let me bring this full circle and answer the question we began with. Light has no mass. So why is its speed limited? The answer is that we have been asking the question backwards. The universe has a speed limit, a maximum rate at which causality can propagate, at which cause can lead to effect, at which changes can spread through space-time, at which reality can update itself moment by moment. That limit is a fundamental property of space-time itself. It emerges from the structure of space and time, from the way they are woven together into a unified, four-dimensional fabric. This limit exists because space and time are not infinite and absolute, as Newton thought. They are flexible and interrelated, as Einstein showed us. They warp and bend around mass and energy, creating the phenomenon we experience as gravity. The cosmic speed limit emerges naturally from this structure. It is not imposed from outside. It is not an arbitrary rule. It arises from the mathematics of space-time itself, from the way space and time are related, from the fundamental geometry of the universe. Light travels at this speed not because of anything special about light itself, but because light has no mass. Having no mass means light automatically travels at the maximum speed the universe allows, at the cosmic speed limit built into space-time. Light is simply the universe's speed limit made visible, made tangible, made observable. It is the messenger showing us the fundamental law written into the fabric of existence. The speed limit exists to preserve causality, to maintain the logical structure of reality, to ensure that effects follow causes, that time flows consistently from past to future, to prevent cause and effect from becoming tangled in paradoxes that would make reality incoherent. The finite speed of light creates time as we experience it. It creates history as a sequence of events unfolding in a logical order. It creates the possibility of change and evolution and story, of a universe that develops and grows more complex over billions of years. Without this speed limit, causality would collapse. Time would lose its meaning. Events could affect their own causes. Reality would become paradoxical, incoherent, impossible. You exist because the universe has this speed limit. Your consciousness is possible because information cannot travel infinitely fast, because events must unfold in sequence, because time flows consistently from past to future, carrying each moment into the next. Your memories are real because the universe has a causal structure, a logical flow from past to future, enforced and maintained by the cosmic speed limit. Every time you see a star in the night sky, you are seeing the past. You are seeing light that left that star years, decades, centuries, or millennia ago. This is proof that the speed of light is finite, that information takes time to travel across space. You are looking back in time with every glance at the heavens. Every time you experience the flow of time, the progression from one moment to the next, you are experiencing the consequence of the cosmic speed limit. Time flows because causality flows at a finite speed, creating a temporal structure to reality. Every thought in your brain, every beat of your heart, every breath you take is orchestrated by electromagnetic forces that propagate at the speed of light, by atoms held together by electromagnetic bonds, by molecules shaped by quantum mechanics and relativity. The question of why light has a speed limit is really asking why the universe has a speed limit, and the answer is because reality itself requires it, because the very possibility of existence depends on it. The universe cannot be infinitely fast. Infinite speed would destroy the possibility of structure, of causality, of change, of time, of existence as we know it. Everything would happen at once, in a single timeless moment. There would be no flow, no unfolding, no story, no life, no consciousness, no you. The speed of light, 299,792,4 458 meters per second, is the speed at which the universe processes itself into being, moment by moment, computing each instant from the previous instant according to the laws of physics. And now you understand something profound, something that shifts your perspective on reality itself. Every time you turn on a flashlight, you are not just creating light. You are witnessing the fundamental speed limit of reality itself. You are seeing causality in action. You are watching the universe update itself at the maximum possible rate. That photon leaving your flashlight will travel at exactly that speed, not because it is trying to, not because something is pushing it, but because it is massless and free, and the universe itself dictates that massless, free things travel at the cosmic speed limit, the speed woven into the fabric of space-time. You now understand something deep about the nature of reality. The speed of light is not a quirk of photons. It is not an accident. It is not an arbitrary number chosen by the universe for no reason. It is the heartbeat of existence. It is the rhythm at which reality unfolds, the tempo at which the cosmic symphony plays itself into being, the speed at which the universe thinks itself from moment to moment. And you, right now, are part of that symphony. Your existence is a consequence of the cosmic speed limit. You are made of atoms held together by electromagnetic forces propagating at the speed of light. Your thoughts are electrical signals moving through neurons at speeds determined by the electromagnetic properties of matter, properties that ultimately trace back to the cosmic speed limit and the fundamental constants that define it. You are a pattern of information, a structure in space-time, constantly updating, constantly changing, constantly interacting with the universe around you, all at rates governed by the fundamental structure of space-time itself. You are the universe experiencing itself, processing information, contemplating its own nature, all at speeds limited by the cosmic speed limit that makes reality possible. The next time someone asks you why light cannot go faster, you can tell them this: light is not slow. Light is as fast as reality allows anything to be. Light travels at the speed of causality, the speed of information, the speed at which the universe updates from one moment to the next. The real question is not why light cannot go faster. The real question is, why does reality have a speed limit at all? And the answer is profound, beautiful, and humbling. Without that limit, there would be no reality as we know it, no time flowing from past to future, no causality connecting events in a logical sequence, no structure organizing matter into galaxies and stars and planets, no life emerging from chemistry, no consciousness contemplating existence. No, you, sitting there now, reading these words, thinking these thoughts. The speed of light is the speed of existence itself, the tempo at which being unfolds from the void. This should fill you with a sense of quiet wonder, with deep appreciation for the intricate, beautiful, precisely calibrated structure of the universe that allows you to exist and contemplate these questions, to look up at the stars and understand, in some small way, the nature of the reality you inhabit. Before you go, I want to hear from you. Has this journey changed how you see reality? Has it shifted your understanding of space and time and existence? Share your thoughts in the comments. I read every one, and I am genuinely curious about how these ideas resonate with you. And if your understanding has shifted in some way, if you see the universe differently now, share this with someone else who might appreciate seeing existence through this lens, who might find wonder in these deep questions about the nature of reality. Consider pressing the like button if you have made it this far, if you have stayed with me through this long exploration of one of the deepest questions in physics. You have completed a journey through some of the most profound ideas humans have ever discovered about the universe. And remember this as you move through your day. Every photon you will ever see is traveling at the maximum speed the universe allows. The speed of light is not light's speed limit. It is reality's speed limit, the cosmic boundary built into the architecture of space-time itself. Light is simply the messenger, the visible manifestation of this fundamental law, showing us the deep truth woven into the fabric of existence, that reality has a speed, a tempo, a rhythm, and that rhythm is the speed of light. Thank you for taking this journey with me into the heart of one of the universe's deepest mysteries. Until we meet again, keep looking up at the stars, keep asking these profound questions, and never stop wondering about the magnificent, mysterious, beautifully calibrated universe we call home. This cosmos that gave birth to stars and planets and life and consciousness, all governed by laws written in the language of mathematics and light.